Go.
Fantastic. Well, great for everyone to be here today, tonight, depending where you're based. So my name is Rod Rivera, and I want to introduce you today about what it means to uh, build AI products for regulated industries. So a little bit of my background is so that I've been working in AI now for the past 15 years across all areas of the industry. So from doing data science, building machine learning, engineering. I also did a PhD in machine learning. And this was before there was this AI revolution. So it was still working with deep learning, but very different as what we do today. So I have seen it from many angles. And now I'm primarily focused on pretty much this angle of working in regulated industries. And I want to share a little bit of the things that I have been seeing and some of the learnings that I have been making. So from that, as well as how does it compare with so what we have, let's say from the classic demos and prototypes that we do. So for chatbots and all type of AI products that we're building these days. So what are like the key takeaways for today? Is that on one side, we have to think in for regulated industries, we have to think about topics such as data privacy, compliance, and cost control. These are this is very different to, for example, when we think about building a startup with AI, where data privacy might be less important, or maybe there might not be compliance at all, and also where cost control might not be that crucial because potentially we're being financed by an investor. The other important aspect is that normally in a regulated industry, the deployment of these models, of all these architectures, will happen self-hosted. It will not happen in the cloud. It will not happen with Azure, AWS, Google Cloud, but it will be in our own infrastructure, be a private cloud deployment or a data center, a server on-premise in some basement. And this has some challenges that are very different to what we have in a regular industry. And then, of course, the number one application that is happening right now in this type of industries is RAG architectures. What are they and so on, we'll discuss it a little bit, but nevertheless here, the important takeaway is that if there is one thing that one is right now asking for, that one is really deploying in a regulated industry, such as a bank, such as a, for example, a hospital, it is a RAG application. So why is it that regulated industries want from AI? Well, it's primarily two things. It's on one side, they want that is safe with full control. Ideally, it should be, let's say, like a transparent model, like a linear regression, or some sort of like tree. And so we really know why these decisions are being made, that we really know the ways behind. And the other thing that we want to know is on the compliance side. So we really want to have some track of what is happening, of all activities. We really want to have fine-grained user controls. Also, we want to know what was the output, what was the input of this. There must be a trail of all activities. And these are like two things that, if we think about AI these days, this is not really the case, right? So already with LLMs and so on, these are not exactly transparent models. These are not necessarily things that we know what they're doing. And not only that, but also we don't really know how we can control the output. We don't really know how we can have actually any type of control over them pretty much. We can have some techniques in order to get more control, yes, of course. So some guardrails, etc., but still always very limited compared to what a regulated industry will expect. And on the topic for the compliance, well, here it means that we need to build a lot around the model. So in order to make it usable for a bank, for example, where just, let's say, like calling the OpenAI API is not sufficient. We're still missing a lot of gluing code, a lot of components in order to make this possible. And if we look at building products at the moment, so as a prototype, as a startup, and so on, pretty much the first thing I will resort to is working with OpenAI. And so sure, there are other providers in the market, but OpenAI must be having 80% of the market easily. And this has some benefit, of course, because they're a really good company. Their services and products they provide are fantastic, no doubt about it. But at the same time, we're relying on them. And there has been, of course, reports of sometimes they are not responsive, they throttle the API. If we want to query it, it is not available. And this is a problem because when we're working in a financial service industry, in a bank or in an insurer and so on, this needs to be always available. Yeah, so we cannot really depend on a third party. A consequence also of this third party is that there is poor latency, meaning We send the query, we send the request, and then we need to wait for that. And in some cases, this might be acceptable, but very often this is not the case. And also, if we think about how a modern AI application is built today, it's not just one single request that we're sending to a model. It's not just, let's say, like a prompt that we're sending to GPT-4, but it's actually most of the time multiple queries that we're sending. We can be using multiple techniques in order to, for example, aggregate response and so on. So as a result, when the user asks for something and then the result comes back, this can be 20 seconds of waiting time. In some cases, this might be acceptable, but in many cases, it's not. And then another topic is, if we go back to the idea of we need compliance, we need also transparency, is that in the end, these are black boxes APIs. We don't really know what it is. And also, unless we are, for example, using OpenAI through Azure, if you're just using Azure or OpenAI directly, we are basically giving away also our data to the vendor, to OpenAI in this case, which is also something that we do not want to be doing. Yeah, so we want to have full control of our data. And not only that, but also what are like problems of all this? On one side, it is this topic of the data. Yeah, so we are relinquishing of the information that we have. Not only we can go into the idea of data is our edge and so on, but also in these industries, if we think about healthcare, if we think about like patient acts, if we think about bank records and so on, we cannot be sending them away. This one thing. But also another aspect is the topic of that there is not a there is no control on the costs. We are calling these queries, and every time that we're making a call, we're incurring the costs. And these costs can get out of control very, very fast. One of the most common things that I hear from companies, it is how they say that they were surprised between the costs that they were having when they were developing their prototype, when they were preparing their solution, and then the final results that they had once they roll out this in production. It was not the same. So working with, let's say, like 3, 4, 5 users, and then they roll out to 600, 1,000, 2,000, 10,000 users, and so on. And not only that, but also the topic of the potential risk and privacy risks. So where they, by using these APIs, so this has been exposed, and then as a result, this is security risk. This is something that is not acceptable in a regulated industry. And on this topic of the cost, what do I mean by that? It is that there was last year this article from the Wall Street Journal that said they were reporting in the case of GitHub Copilot, where it charges $10 per month, but in fact, it is significantly more expensive for GitHub to finance this. On average, it's $20, and in some cases, it's up to $80 per user, because we know there is a lot of intensive usage. There can be a lot of users in our organization that are using this very often, daily, multiple queries at the same time. And then this cost compound, right? And then also, if we're working with better models, more precise models, let's say GPT-4 4.5 turbo or others, then this adopts so fairly fast in the bills that we have to pay. And in the case of a regulated industry, where in a bank and so on, so there are budgets that they will be approved, so years in advance and so on, this uncertainty of not knowing how much will be paid in the end, this is problematic. Ideally, it should be something where one says we'll be allocating this budget, and then by the end of the month, this is met. What is the alternative? If this is a variable cost, well, as soon as you reach the cost, the available budget, then you have to stop providing the service. In some cases, it's possible. So when one is having a small prototype, when one is having a proof of concept and so on, but more and more in regulated industries, we're having the case of providing to every employee their own knowledge worker, their own copilot, and so on. So it means that tens of thousands of users, they are making use of these copilots and they depend on them. So it's not possible to just stop it. Or, for example, another alternative could be of saying, oh, let's switch to a worse model. So we will jump in from GPT 4.5 Turbo to GPT 3.5 Turbo, and then we will save cost by this in quite an order of magnitude. The problem behind, of course, is that in many tasks, we'll be getting worse results. And this will affect the user experience. If a user is already used to the responses that GPT-4 is giving us, and all of a sudden we have a GPT 3.5, well, this is problematic. So working with a cloud service that is a black box, and on top we don't have control of the cost, is an issue. And not only that, but also what is it that these regulated industries are looking for in so working with AI? Well, they of course want that the data is handled. So if we are a vendor and working with the regulated industry, of course we have to provide SOC 2. We need to be hyper compliant and so on. Also explainability, and so that everything is really well documented. And this also again limits the options, because in the case of, let's say, most cloud service and so on, especially with startups, very often they do not meet these compliance requirements. They are not SOC 2 compliant, they're not like hacker compliant and so on. So what is the solution for these industries? What is it that we can do in this case? Well, the first one is that we should self-host these models, not depend on working with OpenAI, Anthropic, whatever it is, but rather we should be using open source models that we self-hosted. Also, not only this, but by using these open source models, we get the benefit of having the cost control, because now it becomes a fixed cost. The cost that we'll be having is pretty much the GPU cost. Here, the challenge, of course, is that we need to know in advance what is it that we'll be building. We need to estimate this and say, based on this application, I need to buy so many GPU cards and prepare them, which is also a challenge. It's not trivial to assess, one, what are the GPU requirements that we'll be having, and two, in the end, how this will translate into so the exact GPUs that we need to be buying. So it's something where many industries, many companies, they struggle with that. And then also through this, by self-hosting and using open source models, then they can ensure this compliance and security, because then everything is now located in-house. But this question of then, if we're self-hosting and then we're buying these GPUs and so on, then what is it that we can build? What are like the applications that the companies are asking? So in a bank, in a insurer, in a hospital, and so on. Well, there are pretty much like 4 categories that we can establish. One side is like search, so semantic search, enterprise search. Anything that is connected with going through document searching, it is highly demanded these days. It's, I would say, like the #1 use case that we're seeing in regulated industries. So you can think that most organizations, they have millions of documents of all types, PDF files, Excel files, Word files, and so on. And finding them across multiple servers, SharePoint servers, legacy systems, and so on is non-trivial. So developing these type of applications, there is a lot of demand behind that. Then some type of summarization, in that not only is about finding the right document, but it's about trying to extract a summary from that. In many of these organizations, you think about like a bank, the documents that they deal with, they are like hundreds of thousands of pages. And therefore, it means that in order to understand what is behind, we need to offer some functionality for summarization. Connected to this is the topic of interrogation, of being able to ask questions about a specific document and say, what is it they say about this? What is it located in this table, and so on. It's also non-trivial, because if we think about large organizations, we also have the situation that they are international, they might have multi-language, and then it can be that a colleague in another country who is not proficient in a language, they need to find information that is in a different language. So being able to ask in their language to extract information from a document that is located somewhere in their servers, and then get this in their own language, this is something also that is highly interesting. And then also related related with this is on generating answers based on this information. Okay. Great. So we want to enable these applications, right? So and ideally we want to do this with open source models. And make this a bit larger. So what's here? Like this. Yeah. So we want to enable these applications. And in the end, all these applications, so at its core, is pretty much working with so JSON responses and so on, right? So it's pretty much like, if we think about search, if we think about summaries and so on, this what we're having is we're passing prompts in a JSON format in different functions. So it can be like a context prompt and a question prompt together for a search application. It can be just the text prompt for summarization, a prompt also with questions for interrogation and so on. So all of this in the end, this is something that is an evolution of what we're using working with just regular, so here, ChatGPT or GPT-4, so working with the API. And in the end, so this is really like this RAG architecture. So where if you cannot use it or have it, the idea is that what we're doing is that we are combining on one side a user query and data we have stored. So for example, we're saying companies have all these files that are in SharePoint servers. What happens is that these get converted into a vector representation. And then what we do is that we store them in a vector, some vector database, or not even that. So one of the questions also that I get asked frequently is which vector database to use. And here my answer is, if you're starting, especially for a prototype and so on, you don't need any vector database. You can use Postgres, because in the end, this is just a numerical form, and you can add like a new column. So for example, of your records and add an extra column where you have like the document there stored. Or you can use plugins such as pgvector. So in the end, you don't need a vector database in the beginning. Yeah. So but nevertheless, you need to store this somehow. And then what happens is when someone asks something, for example, they'll say, what was the revenue of last quarter? What will happen is that this question, revenue of last quarter, gets converted also into a vector. We do some similarity in between the vector that is stored and this query. And then we retrieve the documents that are the closest to this query. And then most of the time we have another LLM that has that's in charge of generating the right answer, because what we'll get from the vector database is just the documents themselves, right? So it will be, let's say, paragraphs of where it says last quarter the revenue was between this and that and so on. So you know, this is something we can really display to a user. So then when one is developing this type of enterprise applications, what happens is that we have on top of the response that we get from the database another LLM that has as a task to aggregate this information and generate a nice answer, such that we can have a sentence such as last month the revenue was so and so. Nevertheless, it is non-trivial. There are some things that we have to consider. We might think that this is an easy architecture, but in practice it is rather challenging. Okay, I'm sorry for that. There is one reason why, if you have been following the press, this type of announcement, such as the one from Klarna, was really successful. It was really published everywhere, and this is because it is rare, and once it happens, it really triggers a lot of interest in the press and the industry. But we don't really see many of them, right? So we do not see companies declaring how much money they're saving or their success with AI. And there's good reason for that. This is because really doing any type of AI system on enterprise level, it is extremely hard. And the results tend to be much more modest than what we believe. So although we are all of us here striving to do good things, in practice it's much more difficult. And this is really because what we estimate as a prototype system is very different as what we have in production. And there are reasons for this. One is, for example, that if we look at the surveys of what enterprises are using, and from our discussion just now, we're saying that not one model is not sufficient. And this is also what the data is showing. So, for example, there is this survey that A16C, this famous venture capitalist, they carry out across multiple enterprises. And the majority of companies who are working with with generative AI, they're using around 3 models for their systems. And this means that we need to understand which 3 models they are and so on. So is this slide that we were discussing before. So where if we think about our RAG application, which 3 models can they be? On one side, we need a model that generates these vector embeddings. And for example, if we think about the enterprise and we think also like self-hosted, something such as sentence embeddings. So from Hugging Face, sentence transformers is called the library. It is a very reasonable way how we can generate embeddings without, for example, using the embeddings API of OpenAI. Then it's a question of, so what we'll be using in order to retrieve these embeddings. And then here again, there are multiple options. So they can be like open source or closed source. Likely, these need to be like larger models than these smaller ones that we get, for example, from sentence transformers in Hugging Face. And then the one that generates the answer that will display in the screen. So in a enterprise system, it can happen that, let's say, these embedders, so that we have here between box 1 and 2, they are small models, they are very simple models. And they might not, sometimes they might not even require so GPU, they can even run in CPU, some of them. But whereas the other ones that are responsible for like ranking the answers and also generating them, they might be much more larger and heavier models. They might be so models such as Mixtral or Llama 3, and not in the small version, but in the larger version. And knowing this is difficult because, yeah, there are so many models in the market right now. So if you just go to Hugging Face and just see how many are available, it is very hard to follow. We just now we're discussing on here this ranking of models. And indeed, cloud models are now the leading ones, but the pace how open source models have been catching up, it is astonishing, pretty much. And we can pretty much believe that this will keep improving over time. This will not remain stale. But sometimes it's a challenge for us. We need to constantly be looking at which are like the better models. If we think, for example, what is like the main argument for using something such as LangChain, it is the idea that you can swap models with just one line. But it's much more than that, because if we look at the ranking and we see, hey, now GPT-4 Turbo is the best one, but I'm still using GPT 3.5 Turbo, we know from experience that the prompts that we have, they are not swappable. If you put the same prompt in two different LLMs, you get very different results. And if you are, for example, trying to add guardrails, and in the prompt you're saying, do not say this, do not do that, and so on, by swapping the LLM, you lose this notion that you have on what is supposed to work or not. So it means that pretty much swapping the model might mean almost like rebuilding your system. So it's not trivial. It comes with costs associated, and requires also like a lot of like thought on which system I'm designing, which elements will go into that, and thinking into the future, which ones might be potentially be replaced or what I may need to change. And on top of that is also the question of you might be restricted. It might be that, for example, your company needs to work with a specific vendor or might not be able to work with OpenAI and so on. So you might say, I want to work with OpenAI, but your company is restricting it. Or the other way around, you want to push an initiative working with Llama 3 as an open source model, but the company has already an agreement in place with OpenAI. And for example, GPT 3.5 Turbo is not anymore in the top 10 of best models, but still, I will argue that is the most popular model being used across companies, not necessarily in the enterprise or industries, but in general, just industry is the most likely most popular model being used. And then if we're thinking about, so which libraries and what are companies using in order to make their products better, their AI products better, then there are like pretty much two blocks. One is development, and then one is like testing evaluation. On the development side, definitely Haystack, LangChain are like the most common ones. And for testing, something such as Ragas in order to evaluate the prompts, and something such as eventually AI in order to also like assess like the queries and so on. These are very useful and that are really used in enterprise setting, because it's like this question we were just having a few minutes ago. You want to understand what are users requesting. You also want to understand how is the LLM reacting to this, and you want to have some control over it and maybe add some business logic on top. And you might be saying, oh, but on Hacker News, they always criticize and speak badly about LangChain, and they say that it's useless and so on. For some people, that might be the case. For some people, they might argue that that's a lot of overhead. But reality is that they are starting to become standards. And for example, I am in London, and then if I go now and then look for jobs that list LangChain, that are already appearing. So also companies, especially in the industry like banks and so on, they're using these frameworks as a way to understand who to hire for their AI initiatives. So you as a professional, if you want to grow and then start working with enterprises, it might make a lot of sense to learn LangChain very well, even though you might think I might not need it. But this is one, how companies are understanding the talent, and two, also the benefits of working with a framework, that it comes with best practices, it comes with structure and so on, and it enables that as a team grows, the team can use the same framework. So definitely, although often it might get not the best press among hacker circles, something such as LangChain is a great alternative and something that enterprises are actually using and asking for. And the topic of like self-hosted, so we're discussing on, so here, the models and so on. There is open source, pretty much free options largely that are for self-hosting your models. And so there is Olama, there is a TGI from Hugging Face, and there is VLLM. And this pretty much enables you to use the popular models that you find on Hugging Face, and then be able to run them in your own infrastructure with different degrees of difficulty. So, and this is like one of the challenges. So that what are the pros and cons? Well, self-hosting sounds easy, but there are some things to that. One is you really need to know what you're doing. So these libraries that I'm showing, so Llama, VLLM, TGI, they're not exactly like they don't run by themselves. So they, in order to use them in production, you need to do quite a lot of stuff. You need to know what you're doing. As a result, the time to market is affected. If you need to develop a lot of infrastructure behind, but then not necessarily you might get the product ready on time. And then, of course, the development costs. So where it is often very much more expensive to hire a good developer, a good AI engineer, than just, let's say, like paying to a third party, so a cloud provider, in order to provide you with this solution. And on top of that, what are like some of the problems of these solutions themselves, of Olama, of VLLM, of TGI? One is that they're not really meant for multi-tenancy, meaning the idea behind it is pretty much, especially for something like Olama, is that it runs on your laptop and it runs, let's say, for a single user, for a single application. But then what happens if you want to have multiple, if you want to have this idea of every employee in my company needs to have their own ChatGPT smart assistant? In that case, theoretically, you will need to deploy an instance of Olama for each of your employees, which will become very hard to manage. It will become very, very problematic. Nobody does that. On top of this, these are not solutions that really a company, an enterprise, can just start using them. Let's say like flipping a button, that doesn't happen. You need to still write a lot of code in order to make them use, especially like glue code and all this topic that we're discussing, like logging, testing, access, so user controls and so on. They do not come with that. And whereas Olama is almost something directly straightforward, where I just install something with pip and I can just choose there which LLM I want to use. For something like TGI and VLLM, you need to write quite some extra code in order to just have this running as like a hello world. And then one of the things also is that these are still very recent young tools. They're very novel. And as a result, they're not really success stories in the enterprise. So also this is like another thing in that when you're working with regulated industries, they tend to be very cautious. They tend to want to use what others are using. They don't want to risk or bet on proven technologies. So trying to sell them on saying, hey, let's start using Olama, it is not easy. It's not easy to also like VLM and so on. These are like popular solutions among hacker circles, among like data centers and so on. But in an enterprise setting, we're still very early for that. Maybe in the future it changes, but at the moment, it's still difficult to convince them to adopt these technologies, these specific libraries. One options, so for example, in the case of the enterprise, is so here Titan ML, Titan Takeoff, that they provide a inference stack that enables to do similar so activities as here Olama, as TGI, as VLLM, but with things that the enterprise requires. So where it comes with so different models that already enable that already save you from needing to program these all this glue code. Also, for example, of model caching is something we didn't really discuss, but one way how you can do, how you can make a model faster, how you can discuss the latency cost, is, for example, of pre-caching the query on an SSD file, or for example, asking an LLM common queries and then caching them in an SSD and then retrieving them from the SSD instead of from the LLM, so directly. So all these tips and tricks that are so discussed in academic circles, they are being implemented, for example, in solutions such as TitanML, and it's something that if you're considering in working in an enterprise setting, might be an option to try. So what are the key points from today is that I see two things. One is, if we think also regulated industries, one is self-hosted. Don't work with so open APIs. Don't work with so open AI, cloud APIs, but rather see how you can use something such as Llama 3, which, as we're seeing in the ranking, it is on the same level as GPT-4 or Bard, Gemini Pro. Yes, it has its own challenges, but if you're in regulated industry, you're working in healthcare, likely it is your only option if you want to deploy these generative AI models. And two, the number one application that companies are having is RAG. And here's like another thing where I see often a lot of discussion, especially like in hacker circles, data scientists and so on, that people talk a lot about agents. Everyone's very excited about agents. But enterprises, and more so regulated industries, they're too far away from that. And also, there are not yet cases that are relevant for them. Rather, the case that companies have is, how can I take these documents that I have that were generated over decades and then make sense of them, enable that people get access to them much more easier. So self-hosted and RAG for the enterprise, this is